Hi, this is Randall Schwartz, host of Floss Weekly. This week, Aaron Newcomb joins me. We're going to be talking about the Snickerdoodle. It's not a cookie, it's a hardware board you can do a lot of things with. Too many things, perhaps. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by CacheFly at CACHEFLY.com.
This is Floss Weekly with Randall Schwartz and Aaron Newcomb. Episode 360, recorded October 27th, 2015. Snickerdoodle. This episode is brought to you by Drobo, a family of safe and expandable, yet simple to use storage arrays. Drobos are designed to protect your important data forever. Visit drobo.com/twit and use the code TWIT100 to save $100 off a Drobo Mini, Drobo 4-Bay, or Drobo 5N. And by DigitalOcean, simple and fast cloud hosting built for developers. Deploy an SSD cloud server in 55 seconds. Try it today for free. Visit DigitalOcean.com, and once you sign up, be sure to enter the promo code FLOSS in the billing section for a $10 credit. It's time for Floss Weekly, the show about free, libre, open source software. I'm your host, Randall Schwartz, Merlin at Stone & Chacum, bringing you each week the movers, the shakers, the big projects, the little projects, the open hardware projects recently. A lot of good stuff done in that area. I'm joined today, once again, by my wonderful co-host, Aaron Newcomb. Aaron, welcome back to the show.
Good morning, Randall. How are you?
Well, I'm a little more chipper than you, apparently, but I've only been up since 5 a.m., and this is a long slot here. So for those of you that are watching the video stream, behind me is beautiful downtown Santa Monica, and the sun is actually probably in frame somewhere that we're hoping it's not going to mess us up too much today for today's show. But I am back on site for ZipRecruiter, doing some really cool stuff for them, and we're also taping Floss Weekly this time in the morning, every Tuesdays now. Every Tuesdays? That's not English, Randall. Apparently, I am really going crazy here. And where are you speaking to us from, Aaron?
My home, in my study, my lair, where I do all my work.
Okay, well, the project today is Snickerdoodle, which is yet another one of the wonderful projects that have come out of the Crowd Supply. We did Crowd Supply, I think, about 4 weeks ago, and just last week, Guillermo and I talked about Nematoopsis, I think it was. Is that the name of something? Nematoopsis. And so this week, it's another open source, open hardware project. I think you know a little bit about this. Can you sort of describe what this is about?
Yeah, you know, I heard about Snickerdoodle just a couple weeks ago, and I immediately was interested in it for a number of reasons, and I won't go into all of them right now because I want our guests to do that in just a second. But it does look like a really cool board, especially because it has a lot of pins to go do things. So whenever you're building something with all these new boards that have come out, it's important to have a lot of interfaces so that you can light up lots of lights or control lots of motors or build a robot or something like that. And in a lot of cases, these small boards, here's one here. This is the Odroid C1. And if you can see, it's got a row of pins up here, and it may look like a lot of pins, but it's really not. There's not that many pins there. There's 40 pins. But some of them are reserved for some things, and some of them are reserved for others. You can't always control what you want to control. But I'm a big fan of all this stuff. I do this every day. I carry this stuff around in my backpack. I'm building stuff every day. Here's another board. This is an Orange Pi. This is the Orange Pi PC. Here's an original Raspberry Pi. That's the original one that came out. Here's this is another Orange Pi. This one is a bigger board. This is the Orange Pi Pro. I've got a couple more right down here. Oh, here's a Raspberry Pi 2, just sitting new in the box. So I've got this stuff all around me. I literally do this all the time. So I'm super excited about Snickerdoodle because it changes things up a little bit. But I'll let our guests describe what they've done.
And also, help me understand this too. That in the Raspberry Pis and those sort of level thing, that you basically just have like an ARM processor plus maybe some hardware that might be configurable. But in the stuff like last week's show with Opsys, and now with Snickerdoodle, we have an FPGA, which essentially allows us to create hardware on the fly. Is that a good description of that?
Yeah, for the most part, yeah. Well, I mean, we'll get more into that, but there's a couple different ways you can do this, and of course, you know, all of the boards that I just mentioned are Raspberry Pi either clones or I use Raspberry Pi a lot because you can run full-fledged Linux on it. And then there's also, of course, Arduino, which is just a microcontroller. It's still very powerful. You can do lots of stuff with it. And then there's FPGAs, and they haven't always been in favor, let's say, with programmers. So sometimes people don't like to use them. So that's going to be interesting, too, to see why they chose to go that route with this particular board.
Great, great. So yes, obviously bringing our guests on in a few moments will be actually the best way to really get this all described. But before we do that, I do have a very important announcement, because we're really excited to welcome Drobo back to the TWiT network. And they're a sponsor of this episode. Digital data is essential to our lives. Drobo is a safe, simple, and expandable solution for all of your storage needs. Drobo offers a family of external storage arrays. You can order them preloaded with storage or add your own drives. I've been a Drobo customer for about 6 or 7 years, and I bought one of the original 4-bay machines. I currently have 4 4-terabyte drives in there, and that means I can store up to about 10 terabytes of protected storage. It means any one of my drives can go out, and it has one, so I know what it's like. But you just pop it out and replace it with another one, and it's up and running again and rebalances all the internal stuff. It's really sort of amazing and wonderful. And so if you're looking for a network-attached solution, either as a local backup solution or to use as a server, you should check out the Drobo 5N. It's simple to use. Getting started is as easy as plugging it into your switch or router. Apps let you back up data to 2 different cloud service providers or sync via BitTorrent Sync. It includes a quad-core ARM processor. 3 of these cores are available to run Linux. Tools for developers also include a full LAMP stack, Node.js, and WordPress. It also supports C, C++, Go, Perl, yay Perl, Python, and Ruby, as well as Git to host your own repo. That's all fairly recent. I'm not familiar with any of this stuff, but it sounds wonderful. Drobos are also great if you work with video, photos, or if you want to set up your own media server. Drobos are reliable. Data received by your Drobo and not yet written to disk is protected if there's a sudden power loss. Even better, Drobos have an internal eUSB device where data is copied if there's a power failure and protects against long outages. It's expandable. You can add or replace drives in your Drobo with ease. No tools required. It's simple. The colored lights on the front of the Drobo communicate status. It's also very fast. It supports Thunderbolt, Gigabit, and USB 3.0 connections, depending on the model. So visit drobo.com/twit to learn more and check out their complete line of products. And when you use the code TWIT100, you'll save $100 off the purchase of a Drobo Mini, Drobo 4-bay, or Drobo 5N. That's drobo.com/twit and use the code TWIT100. We thank Drobo for their support of Floss Weekly. And now let's go ahead and bring on our guests. We'll start with Ryan. Ryan Cousins, welcome to the show.
Hi, thanks for having me.
And where are you speaking to us from?
Beautiful San Francisco, California.
All righty. Let me wave in your general direction over there somewhere. Okay, cool. And let's also bring on David. I can't pronounce the last name. Sorry, Sheltema?
Sheltema, you got it. Yeah, and I'm coming to you from downtown San Francisco as well.
Very good, very good. Yeah, I'm getting better at pronouncing names because I have lots of practice, especially with a lot of foreign language names, which I don't think that is, but that's okay. Obviously, let anybody do this show. So let's start with Ryan. Can you give us sort of the 30,000-foot view of what this project's about and how it came about?
Yeah, sure. So Snickerdoodle we created Snickerdoodle. The concept goes a couple years back now, but the premise behind it is basically providing affordable access to kind of this higher end hardware and tools for makers and hobbyists and students, engineers, entrepreneurs, people who might not otherwise necessarily be able to use or afford these kind of things. So we're coming from sort of a background in developing tightly integrated systems in medical device area, industrial controls, things like that, and realized there were a lot of kind of affordable maker boards out there that effectively give you Linux in your pocket type thing, or something along the lines of an Arduino that kind of gives you these kind of rudimentary building blocks, a really good learning tool for kind of getting started, making things, making stuff. So with Snickerdoodle, we kind of wanted to take that one step further, where kind of providing both elements, both the computational power, that's required, say if you're running Linux, or a lot of people run web servers on their Raspberry Pis, things like that, but also giving people a ton of I/O, so inputs and outputs, and at the same time tying wireless into the whole package. So, obviously for the most part these days, pretty much anything anyone's building has some sort of wireless element on it. So we kind of jammed Wi-Fi, Bluetooth, an ARM processor, and a ton of I/O all into one little business card size computer. And as Aaron was alluding to before, kind of one of the kind of key to the whole thing, or one of the kind of most important features, is this whole idea of reconfigurable hardware and reconfigurable I/O. So not only can your I/O be totally reconfigured, so you can actually adapt it to whatever project you're working on, but you can also actually use the hardware to accelerate specific things. So say if you have some complex algorithm or some sort of image processing application, things like that, that a regular microprocessor wouldn't be able to handle, having both the ARM processor and this reconfigurable element on the same chip actually allows you to kind of seamlessly accelerate those things and adapt things. So like you said, you can change the hardware on the fly. It's probably more in the context of development. So it actually makes it easier to kind of adapt as situations change throughout the course of you building your system, but also after the fact in the field if you needed to implement some new features or new hardware set, new additions, functionality kind of thing to your system after the fact, you can do that as well. So it's a little bit of a different take on the kind of the traditional sort of maker board, which is more of a single board computer style, where you have your standard connectors on there, Ethernet, HDMI, things like that. The interesting thing about Snickerdoodle is it's kind of almost more what it doesn't have, is kind of what makes it unique. So we kind of moved a lot of these bulkier connectors to things like baseboards and whatnot, so you can still have access to them. But if all you really want to do is develop some sort of system that has, maybe it's a mobile battery-powered system or airborne for that matter, and you don't want those kind of bulkier, heavier connectors taking up space in your product, you can get rid of all that to basically just wire directly up to Snickerdoodle and either do prototyping or take a product to market or whatever you might be doing. So that's sort of I don't know, maybe that's a little bit lower than 30,000 feet, but that's the overall idea.
Yeah, well, that's all the time we have for. So sorry, David, we didn't get to you, but no, just kidding. Just kidding. I do want to also look at it from the crowd supply perspective. How did you get involved with crowd supply, and what are they actually doing? What's your relationship with them?
Yeah, it's been interesting. I probably talk to those guys more than they like. I work with them every single day, and so we kind of went through a pretty long process of figuring out which platform was kind of right for us. We heard about crowd supply early on, and then projects got delayed. Of course, nothing ever launches on time, and we kind of went through the whole gambit of, I think we even at one point had projects set up on Kickstarter and subsequently on Indiegogo. And the thing that kind of stood out to us about crowd supply is they're focused pretty much exclusively on delivering physical goods. So which is a little bit different mindset than sort of a Fund My Life or some sort of entertainment focused project that people are working on some of these kind of other creative platforms. But along with that, they have a lot of different mechanisms for helping you actually deliver products. So not just that they're very selective in the types of products that they take on, and that they're, like I said, specifically focused on physical products. A lot of hardware, hardware products that are kind of complementary to what we're working on, but also that after the fact, after you finish your campaign, they have mechanisms for continuing pre-orders and actually services that are aligned with helping you with fulfillment and manufacturing and things like that are of course, you're talking about volume fulfillment for the first time for a lot of people can be difficult things to overcome depending on the scale of it. So that was having kind of an extra backstop there to kind of help us out with making sure that if somebody obviously orders Snickerdoodle, that they're going to get it. There won't be any delays, things like that. So that was sort of a couple of things that stood out to us.
And one more question for you before I jump over to David and give you a brief break here. But what's the status of Snickerdoodle? Is it orderable today? Can I get one tomorrow, or we're still 6 months away or a year away?
So it's pre-orderable today. So we're still obviously in the middle of the crowdfunding campaign right now. I think we have 25 days left, give or take. We're at about 85-ish% of the goal. Oh, there you go, or 86. There you go. So, you know, we're having some alpha units that we're sending out in December. So that's going to be kind of towards a targeted group of people who maybe have expertise with this type of hardware or have a specific application. We've been talking to a number of folks for several months leading up to the campaign, kind of getting some design inputs and different project concepts and things like that, that we kind of want to get the initial hardware units out in the next month or month and a half or so. So those people can kind of hit the ground running and start building the foundation for a bigger community with different reference designs, getting some of the bugs out of the software, things like that. And then any other pre-orders will be fulfilled beginning the end of March.
Okay, cool. That's great answers. I think we're almost done. But I'm just kidding. We got a lot more to talk about in today's show. But David, I want to come over to you for a second. What's your interest in this sort of project, and how long have you been involved with the maker culture?
I work for Make Magazine, and we're the people who put on Maker Faire. And I've been with the company about 2 years. And my interest in boards in general is that boards are a great way to get things done. And, you know, in the maker movement, we've seen sort of a departure from 8-bit microcontrollers, right? Arduino is based on an 8-bit microcontroller, and to ARM chips. And my belief is that the next thing are what Ryan's using, which is a Zinc chip that's an ARM core plus an FPGA. And that excites me. I think that's the next big thing, right? People moved off the 8-bit ARM core the 8-bit microcontroller because they couldn't do floating point math. And they were trying to make, the CNC devices or 3D printers. And so moving to the ARM was sort of the solution for not being constrained by the 8-bit micro. And I think people are running into constraints with ARM cores, and they're looking for something more. And my belief is the Snickerdoodle is sort of the first big splash in the next thing of boards. And that's why I'm interested.
Yeah, I was just thinking back. I said I don't really play too much in the hardware space, but then I was thinking back to my early days, back in when the TTL 7400 stuff came out. I remember Dad and I working in the lab. We bought almost everything that Popular Electronics had to sell, and we could drop chips into it and do wire boarding and things like that. And that's,
right.
That's all. I'm gone from all that though. Now it's a lot more cooler. That's why I was thinking, if I can load software and it rearranges the gates, that seems like a right. Really opening space, right?
Well, and Randall, if you're a software guy and your audience is software, the Snickerdoodle is for you. I mean, FPGAs are kind of the hardware for software engineers, and I think they get a bad rap because they are sort of a black box of only a few people at the company know how to use them, and really I think they're the kind of the ultimate board for software engineers to really thrive on. Ryan can talk about how Snickerdoodle is laying out configuration files for remuxing pins and all that, but I think that if you buy an Arduino right now, or you buy a Raspberry Pi, you want to accomplish a project, you have to do hardware engineering, and I mean that at like a hobbyist level, right? You have a breadboard, you're adding extra pins, you're adding shift registers, whatever. But with a Snickerdoodle or with other FPGA boards, you're just writing code. You're not laying things out in a breadboard. You're connecting the fundamental points of actuation, right? Motors or LEDs, right to the board itself. And that's my position of why it's a software board. And I think that's exciting, and I think it's new. And I don't know, I think you might be into it. I don't know.
Yeah, I mean, it is new, and I think you're right. I mean, I a lot of my projects, I quickly realized that I'm almost out of pins, or out of usable pins. I may have pins left over, but they're ground, they're power, there's something else that I don't need. And so it's like, okay, well, I've got 3 more things to hook up and I have no place to do it. So how do you expand that? I mean, that seems to be, so that and the configuration issue seems to be solved with this board. And it seems to be perfect for robotics. I mean, was that the main goal of this product, to do more robotics types things where you need a lot of inputs and outputs?
Yeah, that was definitely a big part of it. So that's sort of the the background we come from is basically designing kind of mechatronic, or if you want to call it kind of cyber physical devices, where you do have not only a lot of things that you're interfacing with, but a lot of different things that you're interfacing with. And exactly like you mentioned, even if you don't necessarily max out the just straight up number of pins that you have on one of these kind of more affordable kind of maker board type things, you might very well max out the number of pins that you need for your project. So that's a big part of the whole reconfigurability is not just the sheer number of I/O, because that in and of itself is only kind of gets you one step closer. But having those pins be reconfigurable into something that you want was kind of the key. And sort of along the lines of what David was saying, making that fundamental element of FPGA, of working with an FPGA board easier, was kind of the number one thing that we focused on. So having the ARM literally connected to this programmable logic fabric is different than, just a straight, typical just raw FPGA development board, or a development board with an ARM processor and also an FPGA on it. Having those things actually intertwined effectively lets you treat the ARM processor, which is a dual core, kind of hard processor, as if it were just a microprocessor with a ton of I/O, and the I/O you can actually control. So we have this kind of mechanism for kind of loading up different personalities or I/O configurations to your FPGA via an iOS or Android app. So you don't have to get into the big long slog of digging through VHDL or Verilog and all this kind of more hardcore stuff that kind of Dave was mentioning, that only a select few, I mean, I don't know exactly what the ratio is, but it's probably pretty safe to say that the ratio of software, kind of traditional software engineers or embedded software engineers to FPGA engineers is probably pretty high. So, and there's been kind of good reason for that. FPGA is it's interesting just because it's taken on this, it's almost become a kind of a dirty 4-letter word type thing especially in the maker space, but even in the professional world, had a number of clients. We used to do a lot of consulting work for different, I would say, medical companies and everything, and a lot of them have even shied away from it because of the if you get into FDA certification, things like that, and you have to kind of go through all these massive amounts of code, and you kind of hit a bunch of roadblocks along the way that even just validating the design, basically the whole verification validation process, can be extremely cumbersome if you're dealing strictly with an FPGA. So this is definitely a unique part. There's a couple different some other companies are doing this similar kind of thing, but in terms of the approach, it's very, very kind of maker friendly and very appropriate for people who just, if they know ARM, right? They've run Linux and done all these different things. They can pick this thing up and start working with it right away. There isn't that additional burden of having to download some massive tool or figuring out some totally new programming language, or really understanding even at the very lowest level what it is going on with the gates and things like that. It's very kind of the customization of it is very practical.
Yeah, and you can do some of this on Arduino for folks that aren't familiar. I mean, you could actually reprogram the Arduino chip to do different things, but you're still limited there in terms of what you can do. And of course, you can't do it on the fly. You've got to do it and then load it back up to the system, and then the system is running just that set of instructions until you go back in and erase that chip, reprogram that chip again to do something different. And so this is a lot different. Now, FPGA stands for Field Programmable Gate Array, I think. Is that correct?
Yep.
Okay, so that is, for those that are wondering, I mean, that is exactly what we've been describing, which is field programmable, so something you can reconfigure on the fly. But my question to you is, how hard is it to actually do that with this device? How hard is it to actually reprogram things and get them to work the way you want? Because you say it's programmer friendly, but if you got to jump through a lot of hoops to make that happen, people may shy away from it. So what's the difficulty level here? How hard is it to set those pins to make them do what you want them to do?
So strictly from a an I/O reconfiguration standpoint, if it's basically as easy as, I mean, I know this kind of sounds ridiculous, but it's basically as easy as scrolling through an iPhone app and picking your configuration, and it just gets done for you. So, I mean, the way that we're starting out, just because it's basically the easiest to implement and probably the most practical for most people, is basically giving you a bunch of pre-configured I/O or pre-built I/O configurations. So you have the what they call the bit stream, basically, that gets dumped to the FPGA that then tells it, everything, what to do and which pins to assign to what. So basically, if you can go through these menus and say, okay, I want this many SPIs, I want this many PWMs and whatnot, you can just click that and it'll basically program the chip directly over wireless, or you could do it over a wire connection as well. But from an I/O configuration standpoint, it's extremely straightforward. You don't even need to download the tools effectively to do that. Once you kind of get off into the more deeper into FPGA development, say for example you have maybe you go on open cores or something like that and find an IP block that you want, or there are actually several different kind of free, they call them IP, so intellectual property cores is kind of the weird FPGA nomenclature. But basically those are effectively hardware shields in the form of software is kind of a good way to think about it. So, with Arduino, you might bolt on a bunch of different shields for different things that you want to do, whereas with FPGAs, it's all done in software. There's obviously a certain hardware element to it that you can never duplicate from an electrical standpoint and whatnot. But fundamentally, you are rearranging the kind of lowest level of silicon on the chip to do what you want. So, for example, if you want to add a Cortex-M microcontroller, you can literally just pull. I mean, they have microblades and picoblades. There's a couple different IP blocks that are freely downloadable, and that you can actually stick in the FPGA. So that part of it is, generally speaking, very straightforward. The only, the more involved or complex part comes when you want to get into kind of the nitty gritty. Okay, I want to design my own custom, I don't know, video processing acceleration IP, right? So that's when you need to kind of get more involved with the tools and obviously the new syntax and all those types of things, be kind of more aware of the hardware. That's come a long way from ISC, which is an old Xilinx tool. A lot of people, basically everyone in most, or almost everyone in a lot of the forums that we kind of go through just kind of throughout the launch and everything, we'll mention an ISC and say, oh, it's terrible. So ISC, for those who are familiar, was the old Xilinx FPGA programming tool. The new one is called Vivado, which is much more user-friendly and tightly integrated with the parts and all that kind of stuff. So, so that's sort of the kind of secondary layer. If the nice thing is, if you just want a maker board that gives you a bunch of I/O wireless, and you want to be able to reconfigure I/O in a small form factor with an ARM processor, say running Linux. We support Snappy Ubuntu out of the box, and ROS and FreeRTOS and all that kind of stuff. If that's all you need and you don't want to bother with any of the hardware, this hardware mumbo jumbo, you don't have to. You can just literally pick which pins you want, and then ultimately down the line a little bit, we want to be able to people to go in through the app, literally pick a pin that they want to assign to a very specific function and assign it, and then have the back end do the creating the bit streams takes a little bit of time. So offloading that from the user is another benefit that we can provide, basically doing that stuff in the cloud versus on a local machine, because that's to do all the place and route process and all that kind of complicated stuff in terms of actually building up the the actual description of the hardware in a way that the hardware can understand, like assembly language kind of thing. But so yeah, that's a sort of the long-winded, I guess, answer to your question.
No, that's perfect. I didn't have to come back and ask any follow-up questions to that because you did such a good job. That's awesome. David, were you trying to break in and say something there?
Yeah, I was. So I think what may be lost on people who aren't familiar with FPGAs and what Ryan's actually doing with Snickerdoodle is sort of a similar thing to the abstraction and obfuscation of dealing with programming a chip. And a great example of this is Arduino. We use a Java, I guess let's call it an IDE, which basically is a front end for the STK 500, which is a protocol to reprogram an AVR chip, right? Arduino is just a
David there?
I'm sorry? Hello?
I can hear you.
Did I lose you guys?
No, go ahead. I'm hearing you.
Oh, okay. I guess we lost someone.
We lost Aaron.
All right, we lost Aaron. All right.
Keep going. Keep going. Though. Keep going with your answer.
So I think, like as I was trying to say, I think what Ryan is doing is similar to what Arduino has done for the 8-bit microcontroller, but he's doing it for the FPGA, and he's talking about a cell phone app. Honestly, when he told me that his FPGA was reconfigurable from a cell phone, I was glad I was sitting, because that's just not something that people have ever done. FPGAs haven't been easy to use. And I think what's really exciting and what makes this an interesting board for the maker movement is the accessibility and the lengths that the team behind Snickerdoodle is going to make this something that's usable. And that's even before we get into cost, right? FPGAs used to be only something you could buy if you had an expense account and you were on a team working, for some chip design. And that's, for a $55 FPGA, that's really astonishing. And yeah, Ryan can talk maybe more about the cost of it, but this is something new, and I mean, I'm excited about it, and I don't know. Hopefully your audience is, because this really is a board that software people can get behind.
Yeah, well, I've already been saying in the chat room that we have, private chat room that we have, that I wish I had 2 more hours a day so I could play with stuff like this. Now looks like fun. We have a question from the chat room, the public chat room. It says, so what kind of projects, it's from Rexinry, I can't pronounce the name. What kind of projects have been made with it so far, and how reliable is it? Is this as reliable as a Raspberry Pi?
I'm not sure what it's meant exactly by reliable, but I mean they use these in defense and aerospace applications as opposed to washing machines and cell phones. So like
or Roku's, right? I mean,
yeah, exactly.
Let's be honest. Like your USB stack is probably more solid, but yeah.
Yeah, I mean.
Go ahead. Sorry. No, go ahead.
Oh no, yeah. I mean the reliability is never going to be a question. Which I mean, kind of to David's point. I mean these particular parts a few years ago when we first started looking at them were, I think, along the lines of $350 a chip. So they've come down quite a bit in cost, obviously. In terms of projects, we've the last several months we've kind of spent building up the back end more so that we have the, if you want to call it the front end, building applications. There are, of course, dozens of kind of example projects and demos and things like that that we've kind of lined up. It's just a matter of part of it's bandwidth, right? I mean, we're still a relatively small team, but making a bigger priority from us. It's really nice for people to kind of get that visualization, which is something that's pretty much at the top of our list at this point, because kind of showing people what you can do with this thing is obviously a lot more valuable than just telling them you can do it. So that's one of the definitely key things we're going to work on throughout the rest of the year, throughout the campaign. And one of the things that a lot of people ask questions about, for us, the primary focus has been on the developer experience. So doing things like, integrating this kind of iOS and Android layer, which is a pretty high level, tool, if you even want to call it that, down, kind of tying that into this overall tool chain, and then of course, at some point you have to get down to the hardware level. Making that as seamless as possible has been our primary focus, kind of before we get to kind of off track building applications and demos with it, just because our experience with just ignoring kind of the maker stuff, even with professional level embedded development tools, they're usually not that easy to just kind of typically it isn't, the process isn't you plug it in and then 5 minutes later it's running and you're trying out some application on it, you have Blinky running. It's usually a pretty arduous process, which has been kind of just the standard, kind of acceptable status for these things for a long time. So that was another thing. I mean, that's really been our primary focus, kind of to answer the question. So we have a few demo apps kind of up on the site right now, and there's a bunch of things we can point to in terms of robotics, like Aaron mentioned before. We're working with a couple of different companies locally who are either doing robotics research or actually using this technology in terrestrial robots that are driving around. So things with a lot of sensors, a lot of actuators, real-time control, image processing, things like the security robots and whatnot. There's a couple different folks out there using them for autopilots. They're used a lot in communication projects, different sorts of elements of anything that basically requires a lot of interfacing with the real world is kind of ideal for this. So if you just want a desktop computer, you just plug in a keyboard and a display and an internet connection, and you just want to run, a $35 server in your bedroom type thing, you can obviously do that with something like a Raspberry Pi. But once you actually do start hooking up stuff to the I/O, and if you're building something beyond just a couple buttons or a couple lights, something that involves motors and maybe some even encoders or other interface elements like buttons, sensors, lights, all that kind of stuff. That's sort of where you'll basically immediately realize that, while you can probably kludge together something with, say like some sort of weird combination of Raspberry Pi and Arduino and BeagleBone or whatever it might be, having one kind of, as you can imagine, having one tool or one kind of integrated environment for all that stuff it just makes your life so much easier once you actually start playing around with it and going from project to project, which is another nice thing. This is sort of along the same lines of the question, but having the flexibility actually increases the portability of your code, and having one central tool that you can jump from project to project. If you can literally take the same board and that you just built your, say, robot with, that you then plugged into a little gigabit Ethernet router. We have a couple of baseboards and stuff like that for networking or interfaces, that you then use as a single board computer that you then use in a drone. Literally all of the same fundamental building block is a much more pleasurable user experience and development experience than having to start from scratch with maybe either a new tool chain or a new part or a totally new set of I/O or whatever it might be. Be able to jump between designs and even progress any one given project beyond just the kind of fundamental entry level. All right, I built this thing. Now I'm out of I/O, so that's as far as it's going to go. Being able to kind of extend the whole education process and the build process beyond that. That's really kind of where this tool really shines.
Well, and I
Awesome.
think lately. Oh, sorry, Randall.
Yeah, I was just going to say, Aaron, you went away for a second, and now you're back, but we have to pay the bills before we go over to you and let you ask your next question. So whether you're an experienced code warrior or just getting started, you need flexible, reliable, and affordable hosting. DigitalOcean provides developers with Droplets, which are virtual private servers that can be customized and deployed quickly to host websites, web apps, production applications, personal projects, virtual desktops, and almost anything else you could think of with full root access. I myself have been a DigitalOcean customer since back in February when I found out about them at
scale and found out they had a free BSD server, which is my favorite type of operating system. So DigitalOcean is built for developers and used by over 400,000 of them, including me. You can deploy and configure your droplets via a streamlined control panel or a simple API. And you get to choose your OS: Ubuntu, CentOS, Debian, Fedora, CoreOS, and FreeBSD. And all servers are built on hex-core machines with dedicated ECC RAM and RAID SSD storage. The servers can have up to 20 CPUs, 64 gigs of RAM, and 640 gigs of SSD hard drive space. They're highly scalable to meet the demands of a rapidly growing application or business. You can deploy servers in all regions all over the world with gigabit speeds and 99.99% uptime. And there's an extremely active community with a large and detailed set of tutorials on all the ways you can use your droplet. Want to deploy Docker? Set up a mail server? They've got you covered. And it's so easy to get started. You can deploy an SSD cloud server in as little as 55 seconds. DigitalOcean has incredibly affordable and straightforward pricing. Servers start at only $5 a month. There's also hourly pricing available starting at less than a penny per hour. But we're going to make it so you can get started today and deploy an SSD cloud server for free. Visit DigitalOcean.com and create an account. Once you confirm your email and account information, go to the billing section and enter the promo code FLOSS for a free $10 credit. That's plenty to get started and explore what DigitalOcean can do. That's DigitalOcean.com. And once you sign up, enter the code FLOSS in the billing section for a $10 credit. And we thank DigitalOcean for their sponsorship of Floss Weekly. And now, Aaron, ask your question.
So I was going to ask about, you were talking about having this this built-in ability to reprogram the pins, and I think you've seen this in the maker community, especially where you've seen people cobbling together Raspberry Pis and Arduinos to kind of get what they need to do, because they know both. They're kind of in between the two platforms. They need more pins, so they'll connect a bunch of Arduinos up to a Raspberry Pi, let's say, and kind of accomplish this. And so I think the timing here is really fantastic. You mentioned robotics, and I noticed we should probably talk about OS support. You mentioned Ubuntu, but there's also a robotics operating system, right? ROS that you support, as well as a real-time operating system. So could you talk about those are three distinct operating systems to support. Can you talk about why those operating systems, and why not just like stock Debian or some sort of Debian variant similar to what the other Raspberry Pi type boards support?
Yeah, absolutely. So the Snappy Ubuntu was kind of a selection we made, not partially from initial feedback when we first launched the product. A lot of people were asking about it. It was kind of, as we looked further and further into it, it became obvious it was sort of an ideal situation or an ideal OS to support, given sort of the architecture and the kind of targeted applications that we're going after. So it's very lightweight, and it's geared towards kind of internet connected things. And there's Canonical is doing a lot of good stuff, supporting that with their app store and things like that. That have it's just kind of a great lightweight operating system that's obviously Linux based, that is really usable for connected devices, so Internet of Things, robotics, that type of thing. ROS, so we originally started developing this product as a much kind of higher end industrial kind of robotics controller, towards sort of maybe surgical medical equipment, or really high speed communications and all this kind of crazy stuff on it, until we kind of took a step back and looked at this and said, well, there's a lot of people out there that are kind of missing out on this technology. And if we just kind of build something that's aimed at this sort of professional market, it's kind of keeping it away from the people who can really benefit from it. The kind of makers and students and people like that, because just once you price it to a certain point, it becomes inaccessible regardless of how usable it is. But in the case of ROS, we started down the path of, we've been pretty heavily involved with the robotics community here in the Bay Area, Silicon Valley Robotics and folks like that have really been kind of fostering the growth. And it's been pretty amazing how many different robotics startups and things like that I think it was just a thing a couple of days ago. Another, one of dozens of robotics meetups in the area, and Ross has been very well received by the robotics development community, and it's, for those who aren't necessarily familiar, it's a robot operating system. So it's sort of a kind of a weird misnomer, because it's not exactly what most people could consider an operating system. Because it does run on top of Linux. It's sort of it's an interface basically for basically a high level kind of communications paradigm and library set and all those kinds of things for sort of a universal tool for robot builders. So again, the idea of both systems interconnecting with each other, as well as high level communication between different components in a robotic system. It's, as you can imagine, if you have kind of one unified solution for that, you have this massive community who's building up support, with all these kind of open source type projects, totally free and all that kind of stuff. And it's supported directly on Snappy Ubuntu, or by Snappy Ubuntu. So that was, so that's sort of the ROS element. So it's basically, there's very few. What's interesting is there are a lot of different companies and things like that are working with ROS at a software level, but not as many that have tied it to the hardware. Basically saying, hey, we have dedicated support for this, even though it is fundamentally a free open source tool. We're basically saying, hey, we support this. This will work on our platform, because a lot of these other development platforms, you have to go through the process of figuring out how figuring out all the memory management, which can be an issue with the ARM side of things, and all these different problems. We're supporting that directly and supporting the community and kind of building up, making that more robust. And then, of course, the next layer of that, as you can imagine, is sort of the hardware, the reconfigurable hardware element of that, not just from an I/O standpoint, but literally being able to take ROS functions and accelerate those in hardware. And tying those back to different function calls and things like that within ROS. So that's obviously a very powerful concept, especially in a kind of a small, affordable package. And then the third operating system that you kind of referred to was free RTOS. So it's a real-time operating system, totally free, of course. It's fully supported by Zinc, the chip that we're using, and it's sort of along the same lines as real-time operating system, bare metal, kind of the same deal. That's really more geared. It's much more appropriate. Well, it's designed specifically for real-time deterministic controls and functionality. So one of the issues sort of with ROS, it's being addressed in this ROS 2.0 that's coming out recently. There's supposed to be a real-time element to it. But when you get into robotics, medical stuff, unmanned aircraft, all these types of things that require there's some level of safety criticality, which is where we get, as weird as it's spelled a little odd, but that's where we got our company name from. It was safety critical, the critical part of that, and then spelled it in a techie kind of way. But the safety critical real-time element of these systems is something that can probably be overlooked from the standpoint of, say, a maker or hobbyist or someone just trying to get a motor turning, right? Because obviously, if you're running a servo off an Arduino, you don't really care about the real-time performance, probably for the most part. But if you're designing some element, a system that's basically going to be interacting directly with people, or if something goes wrong, something bad can happen, which obviously in a lot of these situations is the case. That's what the real-time element of this particular operating system is for. And there's some really interesting work that a lot of people, it's been going on for a long time now, but in the area of what they call asymmetric multiprocessing. So where you basically have a general purpose operating system like Linux or something maybe with ROS attached to it, something like that, running in one core of the ARM. And then you have a real-time operating system or kind of bare metal level stuff on the other core. So you can actually run your real-time control loops and everything that's kind of deterministic and critical to the safe functionality of the system on the real-time side, and then pass messages back to the general purpose side, kind of communications, kind of giving status updates, things like that, where if that message isn't dealt with right away, it doesn't necessarily mean something bad's going to happen. So that's sort of at least that's one kind of use case. As you can imagine with anything asymmetric, the timing and proper management of those types of messages and controls, things like that, can get pretty complicated once you really dig deep into it, developing, kind of professional level applications. But the idea is basically you can run, Linux in one core. It's, you can have your compiler and all that stuff on the target, exactly like Raspberry Pi. You can program the thing with Python, C++, Java, all that good stuff. And then also have this real-time element where you're kind of doing this more hardcore stuff if you want to. And if you just want to use that second core for maybe Linux, then you obviously can. But the kind of wanted to, part of the idea with Snickerdoodle is to bring together these what have typically been kind of pretty disparate communities, right? You have this kind of higher end professional level group of developers who might only be working in a commercial setting or doing something that's typically kind of beyond someone who's just kind of setting out learning this type of stuff. And then you have kind of the maker and hobbyist who is just kind of into experimenting, right? They have a bunch of more creative ideas and things that a professional, especially in a commercial setting, would never consider doing. But kind of bringing those two communities together into one is part of the beauty of the possibilities of the platform, because you get kind of the expertise from the higher end, and then the kind of creativity and just adventurous nature of makers and hobbyists at the other end. So kind of bringing those two groups together is kind of one of the big things we wanted to do, and it's partially, of course, facilitated by not only the hardware but naturally the software.
Yeah, I think this is really interesting that if you compare this to other projects like on This Week in Google a couple weeks ago, I showed off the Onion Omega that I got off of Kickstarter. And then you think of Chip, and I don't want to go too far into this because we're running short on time now. But I mean, it's interesting because you've kind of gone the other direction, right? I mean, Onion Omega and Chip are super small, definitely Internet of Things type devices, but they have a limited amount of connectivity on them. And so it's interesting that you've chose to go the other way, and I think it really complements those other projects very, very well. I wanted to ask David, you've been doing this for a while, and now you're working at Make, which is fantastic. I'm just kind of curious what you've done in this space, and what kind of things you've done to support projects on open source or open hardware boards.
Sure. So I guess one of the big things I've been involved with is I'm on the Intel Open Hardware Advisory Panel. So kind of talking with them about, hey, this is what open hardware is. They practice some open software, but really advocating that large companies need to be friendly to open hardware, and they have a lot to gain. I think my real interest is finding out about boards that are open hardware, are open source, and really enable the community of makers. I think that the maker movement is really a story about enabling people with tools. And when you do that, amazing things can happen. It's more than just blinking an LED. That's certainly the first step. And you talked about Chip and the Onion Omega. It's the router project, right?
Onion Omega. It's based off of OpenWRT.
Right. So I think actually what Ryan's doing is connected with those, because I think what those projects are doing is they're pushing the boundaries of how cheap silicon can be, and they're getting it. They're democratizing hardware in a way that we haven't seen. If we look to large companies for similar products and specs, you're going to be paying at least $40 for a board, and analogously, Ryan with Snickerdoodle is lowering the barrier on FPGAs, not just because he's developing a cell phone app, but because his board costs $55. And that's just, I think that's pretty revolutionary. And it's certainly, right now, the maker movement doesn't really use FPGAs, right? We have a few that are talked about, but it's kind of the top end, the super technical people in our community who are using them. But, you know, if we talk 6 months from now, I think that's going to be changed. And I think that the board that Ryan is making is going to be a big reason for that, because it's removing the friction to entry. Right? We were talking about earlier why, you know, people take a Raspberry Pi and they bolt on an Arduino. And the reason people do that is because they want an operating system. They want Linux, right? They don't want to just run bare metal firmware, which is what Arduino is. But yet they want to actually actuate things in the real world, right? They want to drive motors and talk to sensors and get analog values in. And you cannot do that on a Pi, right? You can do that with a BeagleBone because of the way the hardware is designed. But you're still adding more and more peripherals to these boards. So the cost isn't exactly $35 on a Raspberry Pi, right? Or on an Arduino, it's not really $29. But if you can reconfigure the hardware to accentuate and really work for your project's goal, which is sort of the case with an FPGA, then the cost is kind of the cost, right? I'm paying for motors and I'm paying for sensors, but I'm not paying for other chips to interface with them. I'm just wiring it up directly to the board, and that's new. And I think that lowers the barrier to entry really a lot, and that's why I'm so excited about it.
That sounds really awesome. You know, we really are out of time, and I really love it. I think we can go another hour easily on this topic. I know Aaron was chomping at the bit to be able to do that, but I'm going to have to leave it right there. But I do have one question. Aaron actually suggested it to me a moment ago. Did we actually just say why the thing's called Snickerdoodle?
That is a good question. I can't tell you there's a great answer to it. We were kind of looking around at different kind of categories of named things. I don't know that could have successors, basically. You know, if that kind of makes sense. So, you know, I don't know. One of the ideas we had at the very beginning was some sort of, you know, Japanese warrior weapons, right? So katana and, you know, whatever else, which is, you know, of course that wasn't quite as friendly, but, you know, we sort of wanted partially to offset the sort of scariness of the idea of an FPGA, you know, because that's not exactly what anyone wants to hear about. But, you know, we also kind of wanted it to be something that's memorable, you know, which I think, relatively speaking, it is. We arrived at cookies. This is a different kind of desserts and all these other kind of ridiculous things that we were looking up to see what the name of the thing. And you know, going down the list of cookies, I mean, obviously Snickerdoodle is the best choice. So there wasn't any sort of real scientific method necessarily to it, but yeah, somehow we ended up with it, and it just kind of stuck. So.
Yeah. Okay. Well, that's great. That's nice. I do have two more questions I have to ask each of you, or else my audience writes in and say, "You forgot the questions. You forgot the questions." So, so we'll start with Ryan first. What's your favorite scripting language?
Scripting language. I'm not a huge programmer myself, so I mean, I'm not sure I necessarily have a favorite. To tell you the truth, I don't want to offend anybody by giving you a bad answer.
Okay. And then what's your favorite text editor?
I mean, I use a lot of Text Wrangler, but
that's cool.
There's been a couple others, but yeah, that's the one I'm using recently anyway.
Okay, great. And David, same two questions.
So yeah, scripting, you know, not so big, but I'll be more of a I guess a starter of a flame war. I'm a big VI guy.
Yeah.
I love it. I write my articles in VI, and it works for me. It doesn't work for everyone, but it works for me.
Okay. Yeah, like I said, we could have got another hour with this show easily, but I think the folks at TNT would really be mad about that. So I want to thank the two of you for coming on and talking to us about this really exciting project, Snickerdoodle, and I'm sure there'll be a lot of people that'll be looking into it now because of that. So thank you, Ryan. Where's the names right there? Ryan Cousins and David Sheltmo. Thank you for coming on the show.
Hey, thanks for having us.
All right. And that was them. Aaron, what do you think? Short.
I'm getting ready to buy one. I need to ask them. I want to get the there's a 1 gig option, but I don't want to delay getting the board. So I don't know if that option is going to delay getting the board or not, because I want to get it quickly. I'll go for 512 meg if I can get the board quickly. So I'm going to be buying one of these right away. The people at our makerspace are going to love it. We have a lot of people that actually hack into Arduino, write their own firmware for the chip, so they can get it to do things that it normally, either isn't capable of or isn't configured for. So I think it's going to be really cool for them. Also, I think this is fantastic for anybody that's building any kind of robotics. We have a guy in our makerspace that builds full-size R2-D2s, the ones you see at the big Maker Fair. He's one of those guys, and this would be, I can imagine this replacing a lot of the components that he has inside the R2-D2 and freeing up space for other cool things that he can do with that. I also think it's really cool for anybody. I mean, this is Halloween season, right? Halloween's just around the corner, literally. And I mean, what if you wanted to run, a big light display at your house and control all kinds of relays? And that would be a simple thing to do with it, but you've got enough pins there to hook up to enough things. You could really do some elaborate lighting projects. And what about home automation, right? Controlling light switches and lights and doorbells and security systems, and you could build your whole home automation system with this thing. So I mean, I think there's a ton of great applications for this, and I'm just really excited to see it and get it and play with it.
Absolutely. I don't have much to add to that, also because we're out of time. So, and it's also, I'm freezing in here. They kicked on the air conditioner a little while ago, and I ran out of warm liquid. So I'm going to quickly wrap up the show here.
You're literally chattering.
I am literally chattering. Yes, it's like, freezing in here. Anyway, so we actually have a full Q4 minus 1 week, I think. So I've been madly sending out emails. We added 3 new guests for between last week and this week. We'll run down the list, though. OPNsense, which is a FreeBSD firewall. We have Dart. Casper Lund is coming on to talk about the changes in Dart over the 2 or 3 years since we had Seth Ladd on, including some really interesting things that are coming up in Dart 2.0. Caddy is a high-performance web server written in Go. Kanoma is advanced JavaScript for the Internet of Things. Might that be cool to run some JavaScript on the Snickerdoodle and make it talk to things? That would be kind of fun. Okay, just add to the schedule, we have Piwik, I think. It's sort of an open source version of Google Analytics for web analytics for your software and sites. Just added to the schedule as well is Tulip, which is application lifecycle management. That sounds really familiar. I think they were on the schedule like maybe a year ago, and I had to cancel on them or something, but they're back. And I'm also very excited about this last thing. So I know, Aaron, you like to play with hardware, but I like to play with simulations of hardware. And so what we have brought on is Stephen Ressler, who's been a guest on a couple of the cruises that I've been on, is he works for the Army Corps of Engineers. He teaches physics things, building, design, construction, that sort of stuff. Yeah, mechanical engineering. There we go. That makes it even closer. Okay. And he and his brother have created a bridge designer that's in software, runs on Linux and Windows and Mac. Actually, I don't think it runs on Linux. I think it's the one he's missing. But what they do every year is they have a contest to see who can build the most elaborate weight-bearing bridges with the least amount of parts. And so it's a full physics simulation software, and they run the contest for high school kids. And their next contest is actually starting in about 6 weeks. So I want to get this show in time so that people can actually start playing with it. And people all over the world are doing it in high schools. High school age people are the only people that are eligible, unfortunately. And Stephen Ressler is an amazing speaker, so I wanted to make sure to get him on this show, or by causing an overlap of universes between my Insight Cruises stuff and my Floss Weekly stuff. Anyway, all those people are listed at twit.tv/Floss, or at least the big spreadsheet that's listed from there. We can always use some more guests, though, but I'm opening up Q1 probably in a couple weeks, so I've got about 4 or 5 people on the short list now that's just waiting for an open slot that fits them, so we're working hard on that. We have a live stream. We took some questions from there. It's 8 a.m. Pacific time on Tuesdays now at live.twit.tv. And by the way, we'll switch back to daylight time. We'll switch back to standard time in about 2 weeks, so if you're someone that's not in the U.S., you'll have to figure out
what that actually means in terms of your daylight savings time transfers as well. Let's please end daylight savings time. It's so annoying. You can follow us on Floss Weekly on Google Plus and at Floss Weekly on Twitter. You can follow me at Merlin on Twitter, but mostly my original material is on Google Plus, and that's Randall L. Schwartz there. I don't have really anything to plug, but Aaron, you want to plug something quickly?
Yeah, sure. Just real quickly, I'm down at Oracle Open World this week. So I'll be down there. It's Tuesday. I'll be down here today and tomorrow down in San Francisco. So if you're in San Francisco and you want to meet up, grab some coffee, get a beer, whatever, just reach out on Google Plus or Twitter is fine too. If you're a Twitterer, that would be fine. Just reach out, let me know, and I'll try to find some time to meet up with you.
Cool. Well, Aaron, thank you for your particular insights on these open hardware projects. I really appreciate that. And thank you for joining me in general as a co-host. It's really been wonderful. So thanks.
Oh, yeah. Always glad to be on.
Great. And we'll see you all again next week on Floss Weekly.